Hi everyone, welcome back to Sri Sampath Vinayaka Learn Easy channel. Now we will discuss exercise 1.4 of the chapter 1 mark, that is real numbers. Okay, in that exercise 1.4, the section 1 is prove that the following are irrational. Section 1 is prove that following are irrational. Okay, in that question number 1 is 1 by root 2. Okay, now see, he is asking us to prove this 1 by root 2 as an irrational number. We know that 1 by root 2 as an irrational number, but we have to prove this one. Then we have to follow the proof by contradiction method. So for that, firstly we have to let 1 by root 2 is a rational number. Okay, now as this 1 by root 2 is rational number, we can express that 1 by root 2 as some p by q mark. Okay, that implies root 2 is equal to q by p mark. Root 2 is equal to q by p. Simply we know that root 2 is an irrational number, but it is in the form of some x by y, which contradicts our assumption. That is why this root 2 is an irrational number mark. Understand mark? So simply we will write, that is, we know that root 2 is an irrational number. But it is in the form of x by y, which contradicts our assumption. That is, 1 by root 2 is an irrational number. Okay, Nama? Let us suppose the same question is given for 8 marks. Then what we have to do means, firstly we have to write 1 by root 2 as a rational number. Then 1 by root 2 is expressed as p by q. Then root 2 is equal to p by q. Now we know how to prove the numbers which are in the form of root 2. That is model 1 mark, root 2, root 3, root 5. Okay, now the same procedure here we are going to follow. That means here we have to squaring on both sides. Then we have to use the theorem 1.6 and we have to follow. But this is enough. Okay, now for 8 marks also this is enough. Okay, I hope you understand this. Now Seema, we will prove root 3 plus root 5 as an irrational number. Our question is, show that root 3 plus root 5 is an irrational number. So firstly we have to assume that root 3 plus root 5 as a rational number. Okay, then this root 3 plus root 5 is going to be expressed as some p by q. Now we have to squaring on both sides to this. Then this is root 3 plus root 5 whole square is equal to p by q whole square. Then by expanding this one as a square plus b square plus 2ab, so 2ab. Okay, now see here square and root will cancel out. Then here we left with 3, here we left with 5. 3 5 it is 15 mark. Okay, now I will transfer this 3 plus 5 to the other side. 3 plus 5 means 8 mark. By transferring this 8 to the other side, that will become minus 8, and it is 2 root 15 mark. I want only the radical value on the left side, so I will transfer this 2 to the other side. While doing so, we are going to take the LCM. LCM of these two is q square mark. Okay, now so p square minus 8q square by transferring this 2. Okay, now this 2 here multiplies by going on the other side, that will divide mark. So p square minus 8q square by 2q square. That is, we know that root 15 is an irrational number, but it is in the form of x by y, which contradicts our assumption. That is, root 3 plus root 5 is an irrational number mark. Okay, now see in this third question, he is asked us to prove this 6 plus root 2 is an irrational number mark. Okay, it is of model Tell me what? It is of model 2. Okay? A plus root b. So, firstly we have to assume this one as a rational number. Let 6 plus root 2 is a rational number. That is 6 plus root 2 is expressed as some p by q number. So I want the radical value on the left side. So I have to shift this 6 to the other side. So p by q minus 6. That implies root 2 is equal to, by taking LCM, here it is 6q by it is q mod. So we know that root 2 is an irrational number. Again it is obtained as some x by y. So if this is contradicts our assumption. Our assumption is 6 plus root 2 is a rational number. So that is wrong. That means 6 plus root 2 is an irrational number. We have to write that conclusion. That is, we know that root 2 is an irrational number. We know that root 2 is an irrational number, but it is in the form of x by y, which contradicts our assumption. That is 6 plus root 2 is an irrational number. Okay, Nama? Now, fourth one. He is asked us to prove this root 5 is an irrational number. This is of model 1. So, firstly we have to assume that let root 5 is a rational number. Okay, Nama? So, we have to write that root 5 as some p by q. So, that is root 5 is equal to p by q. Here we have to write about the p and q, where p comma q are co-primes. Co-primes and relatively primes are the same. Okay, we are going to solve this problem based on that co-primes only. That is why we have to underline that mark. Co-primes and relative primes are the same. That means that p and q are having 1 as the greatest common factor. Other than 1, there is no greatest common factor for p and q. But based on that particular key point, we will solve model 1. We know that. Okay. Now squaring on both sides. Squaring on both sides. Then it is root 5 whole square is equal to p square by q square. Okay, nama. That implies 5 is equal to p square by q square. Okay, na. Now from this I will write q square is equal to p square by 5. So see here, this 5 divides p square exactly. Why? Because here we obtained q square. That means p square, clearly p square is divisible by prime 5. Okay, nama? So p is also divisible by 5. Okay, now this is theorem 1.6. We learned that if a square is divisible by a prime p, then a is also divisible by the same prime p. Similarly, here p square is divisible by prime 5. So p is also divisible by 5. If p is divisible by 5 means that p can be expressed as 5 into something. For example, see, 25 is divisible by 5. So that 25 is expressed as 5 into some value. Okay, na? And also 35 is divisible by 5. So 35 is also expressed as 5 into some value. Similarly, here p is divisible by 5 now. That is p is equal to some 5 into x. Let us suppose 1. Okay. Sorry, let it be 1 and let it be 2. Okay, nama. Substitute 2 in 1. That implies, see, q square is equal to 5x whole square by 5. That implies q square is equal to 5x into 5x by 5 ma. 1 5 and 1 5 will cancel out. Okay na ma? That implies, see ma, q square is equal to 5x square. Okay na ma? That indicates, see ma, x square is equal to q square by 5. Again, the same condition here we obtained. Okay na ma? So, this 5 divides q square exactly. As we obtained here, 5 divides p square exactly. Okay na ma? That we have to write again. Clearly, q square is divisible by prime 5. So, q is also divisible by 5. That is, that q again expressed as some 5 into other value y. Okay na? Here we obtain p is equal to 5x and here we obtain q is equal to 5y. That means this p and q are having this 5 as common factor. But as we assume that p comma q are co-primes, that p and q must have 1 as the greatest common factor. But here we obtain 5 as the greatest common factor. That means we obtained wrong. That means it contradicts our assumption. Why it contradicts means we assumed wrong. Okay na? Then what is the correct value ma? This root 5 is an irrational number. That we have to conclude ma. Okay? From 2 and 3, p comma q are having 5 as common factor. But it contradicts our assumption. That is, root 5 is an irrational number. Okay, Nama? See ma? Fifth question. Here he asked us to prove this 3 plus 2 root 5 is an irrational number. Again we have to prove that one by the proof of contradiction. So for that we have to assume this 3 plus root 2, for that we have to assume 3 plus 2 root 5 is a rational number. Okay, Nama? That is, this 3 plus 2 root 5 is expressed as some p by q. Okay, Nama? Then I have to write all the radical value at one side. Okay, then 2 root 5 is equal to p by q minus 3. Okay, take the LCM here. Ma. Here it is p minus 3q by q. Now transfer this 2 to the other side. As this 2 multiplies here, by goes on to the other side, that will divide. Now see, we know root 5 is an irrational number, but it is in the form of some x by y, which contradicts our assumption. That means our assumption is wrong. What is our assumption, ma? 3 plus 2 root 5 is a rational number. Then what is correct, ma? 3 plus 2 root 5 is an irrational number. That we have to conclude. That is, we know that root 5 is an irrational number. But it is in the form of x by y, which contradicts our assumption. That is, 3 plus 2 root 5 is an irrational number. Okay, Nama? Now, sometimes he may ask us to prove, let us suppose this is the sixth question, 3 minus 2 root 5 is an irrational number. Then here we have to write, okay, now 3 minus 2 root 5 is a rational number. Ma. Now here it is 3 minus 2 root 5. I already told you that we have to express the radical value always positive. Ma. Then I have to transfer this 2 root 5 to the right side and then will bring that p by q to the left. Ma. Then it is going to be what? Tell me, ma. 3 minus p by q. By bringing back this p by q to the left side, this will become minus p by q and this negative 2 root 5 will become positive 2 root 5. Ma. By taking LCM, what we will get, ma? 3q minus, tell me, ma, p. 3q minus p by q. By transferring this 2 to the other side, that will become 2q. Ma. So root 5 is equal to 3q minus p by 2q. Again, we know root 5 is an irrational number, but it is in the form of x by y. So it contradicts our assumption, that is root 3 minus 2 root 5 is an irrational number. That is the small difference between 3 plus 2 root 5 and 3 minus 2 root 5. Just this is the difference here, okay? We have to write this radical value as positive always. Remember this particular point. Okay, Nama? Now, see, ma, the second section of the exercise 1.4. He asked us to prove that root p plus root q is an irrational number where p comma q are primes. Okay. Now, as we know that root p plus root q actually an irrational number, but he asked us to prove. Then we have to choose the proof by contradiction method. For that, firstly we have to assume this root p plus root q as a rational number. Okay, now every time we are assuming that as some p by q, but as we are having the variables p and q here, we are going to assume that as some a by b. Let root p plus root q is a rational number. Okay, that is root p plus root q is equal to some a by b. Now squaring on both sides, ma. So this is root p plus root q whole square is equal to a by b whole square, ma. That implies root p whole square plus root q whole square plus 2 into root p into root q is equal to a square by b square, ma. So square and root will cancel, ma. Here we left with p plus q into 2 into root over pq, a square by b square, ma. So I'm going to write this 2 into pq on the left side and I will transfer this p plus q together to the other side. So a square by b square minus p plus q, ma. Okay, now I will take the LCM. Okay, now that implies, see, ma, root pq is equal to a square minus b square times p plus q whole by b square, ma. Now I will transfer this 2 to the other side, na, ma. Here this 2 multiplies by going on to the other side, that will divide. Now see, this root pq is an irrational number, we know, but that is expressed as some x by y, which contradicts our assumption. Then root pq is not going to be. So listen, ma, root pq is expressed as some x by y here, so that contradicts our assumption. That is, our assumption is wrong. What is our assumption, ma? Root p plus root q is a rational number. Then what is correct, ma? Root p plus root q is an irrational number. That we have to conclude, ma. We know that root pq is an irrational number. But it is in the form of x by y, which contradicts our assumption. That is, root p plus root q is irrational. Okay, Naman? I hope you understand.